Hi, this is part 2 of the peek trick videos. In this video, I'm going to show you the power of the peek trick by teaching you how to calculate how far up or down an object can go when it's thrown pretty much in your head on just about any problem. It's a really great trick to have. So let's jump in with a couple of practice problems. So this one says, a ball is thrown straight up at 10 meters per second. How high is it when it reaches its peak? So I've got just a rough sketch of the problem for you here, where it starts out with an upward velocity of 10, and then it's asking you how high the peak is. And we know at the peak that the velocity is going to be 0 meters per second. So the thing that we're looking for here is what we're going to call delta y. So if you pay attention on the last video, then you should pretty quickly be able to calculate what the peak time is, the amount of time it takes until this thing completely runs out of velocity. If it's getting 10 slower every second, and it started with an initial velocity of only 10, then the amount of time that it's going to take to get to the peak is exactly 1 second. So that's easy, right? If it spent 1 second going up, and it was going at a velocity of 10 meters per second, then the total height would just be 10 meters per second times 1. So you have a height of 10 meters, right? Actually, that is very wrong, so be careful. The ball was not going 10 meters per second the entire time. The moment it was thrown, it started getting slower and slower. So you have to be really cautious here. It spent some of the time going 9 meters per second, some of the time going 8, and all that. So it's a little bit more complicated than just doing 10 times 1. But here's the beautiful thing. We can combine the peak trick, finding this peak time, and we can use the average velocity. Think about it. If the object started with a velocity of 10 and it finished with a velocity of 0, then the average velocity, you just find the middle of those two numbers. So the average velocity on the way up was 5 meters per second. It spent half the time being faster than that and half the time being slower than that, right? But if it had just been going 5 at a steady speed the entire time, you would have gotten the same results. Here's the beauty of it, is if it went at an average of 5 meters every second and it spent 1 second going up, then the peak height is just going to be 5 meters, an average speed of 5 times 1 second that it spent going up. So you get 5 meters. Let's try another one. The trick's pretty easy once you get the hang of it. This next one says, Superman jumps up and over a building. If it took him exactly 6 seconds to do this, how tall was the building? So it always helps a little bit to visualize a problem before you start just jumping into the numbers. So to just picture what he's doing here, here's the building, and he jumps up, and the stopwatch reads 1, 2, 3, 4, 5, 6. If it took him 6 seconds to jump over the building, then he spent the first 3 seconds getting to the top, and then he spent the next 3 seconds flying down from the building, right? Because the amount of time going up equals the amount of time going down. That gives us some really, really valuable information here, particularly that the peak time is 3 seconds. Well, that's nice and all that we know the peak time, but we don't know any other information. In this information, we were told how fast the ball was thrown. It was 10 meters per second. But here, they didn't actually tell us how fast Superman jumped. But think back to the other problems. If it took him 3 seconds to reach the top of his flight, 3 seconds until he completely ran out of velocity, then how much velocity did he have in the first place? I'll give you a hint. Every second, he got 10 slower. If he got 10 slower every second, and it took him exactly 3 seconds until his velocity was completely gone at the top, then we know that the initial velocity, how fast he jumped, had to be 30 meters per second. That's the only way that he would have a peak time of 3. And we also know it's always a given that at the peak, the velocity is 0. So for this problem, his final velocity when he's at the top of the building is 0, which tells me that his average velocity on the way up, if he started at 30 and ended at 0, his average velocity was 15 meters per second. Now here it gets easy. If he went an average of 15 meters every second for 3 seconds, then the building was 45 meters high.